Okay, so in this video here I'm going to be showing you a few examples of writing parametric equations given different pieces of information. If you want to copy these examples into your notes and try the practice problems, tomorrow we'll have a little quick like a homework quiz to make sure you understand what we're doing. So try these out as we go. So the first example says write an equation, a parametric equation of a line through these 2 points, 2, 5 and 5, 1. So I'm going to start off by making a sketch. And so there's my sketch, and we're going to basically write an equation of the line through this. Remember, a parametric equation has a direction or an orientation. We aren't told anything about that, so we can make it whichever way we want. Let's have it go down and to the right. So the way we're going to do this is we're going to create the parameters in a way that's helpful to us, because we're making the equations of this so we can set the parameter to be whatever we want. So I'm going to make our first point P be at t equals 0 and the second point Q be at t equals 1, which allows me to start writing the equations here. So if I want to write my x equation first, what we do is we pick our starting value for x, which is 2. And because we know in 1 unit we're going to go increase our x value from 2 to 5, so that's an increase of 3. So I'm going to add 3 times t. And so for every 1 t unit, we increase our x value by 3. So that brings us to 5. Do the same thing for y. Starting value is 5. And this time I'm going to decrease it by 4. So minus 4t. And if we were to plug in t equals 0 and t equals 1, we'd get these two ordered pairs. So we've created this line. Now how do we make sure the line goes forever in both directions? Well, we restrict our t, or write the restrictions of t from negative infinity to infinity. And so we'll get that whole line. These three pieces in combination make up the answer. Remember, for a parametric you need 3 pieces, an x equals, a y equals, and a restriction on t. So what I want you to do now is pause the video and try out practice problem number 1, which you see below. I'll put the answers up in a second. Okay, there you go. Check your answer to see how you did, and then pause it if you need to look over it, and we're going to move on to our next example. So this one's a similar type of problem, except now we're writing the equation of an ellipse. So the center is 0, 0, major axis is horizontal, is 8 units long, minor axis is 6 units long, vertical. So go ahead and let's make a sketch of that. So to write this parametric equation, we're going to eventually use what we used the other day, the idea that cosine squared t plus sine squared t is going to equals 1, the Pythagorean identity. So what we want to do is start with the rectangular equation that we know. If the center is at 0, 0, and we have our horizontal distance is 4 from the center to the major endpoint, and major vertex, and the vertical distance is 3, we get this equation. X squared over 16 plus y squared over 9 equals 1. We want the form to end up matching the Pythagorean identity. So we're going to pull that squared out and make this x over 4 squared plus y over 3 squared equals 1. And from that we can get that cosine t is equal to x over 4 and sine t is equal to y over 3. And from there we solve it, both of them, to get our x and y equation. X equals 4 cosine t and y equals 3 sine t. And then we need our restriction. Okay. Well, this one doesn't really tell us where to start, so we can assume we start here at the angle 0 and just rotate one time around unit circle. So we'll go from t equals 0 is less than or equal to t is less than or equal to 2 pi. So there's your equation. So take a second, pause the video, and try practice problem 2. So here's the solution to practice problem 2. Check your answer, pause the video, and when you're ready, let's move on to example 3. So this problem is just like the first problem, except I give you the graph instead of you having to make a sketch. The important part here is, though, two things. One, I tell you the orientation is going up and to the left, and also we have a starting point and an ending point. Well, just like before, we'll just call this the starting point t equals 0 and the ending point t equals 1, and that's going to give us our restriction for t, 0 to 1. And then we'll write the equations the same way. X equals, I pick my starting x value of 2. I figure out how much do I add to get to the next one. Well, 1, 2, 3, 4, 5, 6, but we're going left, so really we're adding a negative 6 times t. For y, I start at a y value of 1, and I'm going to add to get to 4, so I add 3t. And then my restriction on t is from 0 to 1. That's it. If we plug in the t values of 0 and 1, we get these two ordered pairs. So pause the video, and I'll scroll down here. Try practice problem 3. And here's your solution to problem number 3. The nice thing about these problems is we get to pick the parameter to be whatever we want, so we can set the t equals 0 and t equals 1, and it makes our restriction pretty easy. Alright, pause the video if you need to, and then we're going to move on to example 4. Okay, in this last type of problem, we're giving a rectangular equation, y equals 3x plus 5. We need to create a parametric equation for it. So what we can do is pick x to equal t. We just say x is going to equal t, and let's find out what y equals if that's the case. So we're going to plug in t for x, and we get the equation y equals 3 times t plus 5, and there it is. There's our x equation and y equation. If we think about this graph, that's a line, and it's going to go on forever in both directions, so we can plug in any t value we want. So negative infinity is less than or equal to t, really just less than, is less than infinity. Remember, we need a restriction. Okay, now it says find 2, though, so the other way we could do it is to start with, well, let's let y equal t. In this case, I get the equation t equals 3x plus 5, and now I have to solve for x, so we get x equals t minus 5 over 3. Same thing here, though. We're going to have a line in both directions going on forever, so the restriction on t is the same, negative infinity to infinity. So either one of these are our two different parametric equations. So go ahead, pause the video, and try practice problem number 4. This one was a little trickier for the second one. The first one, x equals t, and then y equals t squared plus 1. And t is going to be from negative infinity to infinity because we have this parabola that's going to go all the way left to right. For the second one, when we let y equals t, though, we end up solving and getting that x is plus or minus the square root of t minus 1. Well, we've got a square root, so we're going to have a restriction on t because we can't have a square root of a negative. So we set that inside of the square root greater than or equal to 0. So we get the restriction t has to be greater than or equal to 1. And that should make sense because, let's make this an equal sign. If y is equal to t, if we think about our graph, this parabola is, the y values are 1 or above. So t should be 1 or above, which this restriction makes happen. Okay, that's the video. Come to class tomorrow ready to take a little quiz on these types of problems. It'll be a short couple questions, and it's only going to count as a homework grade, but make sure you know what you're doing. Thanks for watching.